Hello everyone, my name is Franco Pucci. I'm the technical consultant for the STS Association. Welcome to Training Video Series 2, where we will explore the companion specifications. I hope you find these videos helpful. In this video, we will be looking at message definition in ASN.1 format and a virtual meter setup. If you recall from a previous video, we showed the DLMS domain entities. Here's a little reminder of it. We are dealing with the STS token gateway, the STS COSEM, which is in fact the token carrier as specified in STS101-2. We also discussed in a previous video the message interchange, the enter method, and I showed this picture of the flow from the head-end system right through to the meter, the validation of the token that has been sent via the token gateway, and then the message going back as an eventual token status to the head-end system. Okay, OBIS identification. Let's look at how the token gateway is specified in the DLMS documents. The class ID for the token gateway is defined as 115 or 73 hex in IEC 62056-6-2. The OBIS identification parameters are defined below. So, the prepayment object is called the token gateway. The class identifier or class ID is 115 or 73 hex. And the OBIS identification is 1940-49-0255. The utility has the ability to select any of the token gateway OBIS codes in a value group D in the range 40 to 49. This value will be defined in a companion specification generated and maintained by the utility. If we choose, say, 40 for value group D, then the OBIS code for this would be 401328FF. A message in ASN1 format. Although AXDR is used as the encoding rule, the message is formulated using ASN1 standards. For a full definition of the ASN1 BER standard, refer to RTU TREC X680 2008-11 and RTU X680-0207 for bitstring definitions. Let's look at a summary of the data elements used for data encoding. You have a token data type, which is an integer format in the range 0 to 99, and the carrier is a request message. The ID record is a printable string, 35 alphanumeric ASCII characters, and that's also in the request message. The PRN record is a printable string, and it's an ASCII string of variable length. Token data is an octet string, 66 bits in the request message. Then authentication, validation, and token result and ID record result all come back, and that's in the response string. They're all bit strings and they're all of variable length. We have already discussed all of these in a previous video, so we'll not go into any of the detail here. Message definition. The document goes on to describe the following: the request message definition and schema, the response message definition and schema, the bitstring values in the response messages, and a worked example showing the use of all the required fields in a request and response message. I haven't put all of this into this video because it will make a long and tedious video. So please look at the document itself if you want to get more information on these. So the specification also goes on to show you, I think, a reasonably good worked example of a request and response message. You can also test your implementation using the STS meter simulator, which supports the STS101-2 and 201 specifications. However, this virtual meter is in beta test at the moment. We are busy testing the virtual meter against hardware meters, and once we have established that the virtual meter responds the same as a hardware meter, and both of us have our implementations of STS101-2 and 201-2 done correctly, we will make it available sometime next year the membership will be informed of this, and then you can actually use this to test your implementation of the DLMS COSEM. This is what the virtual meter with DLMS support will look like. What we've added to this standard virtual meter obviously is all of the OBIS codes supported, where you can enter in your short name, logical name, class ID, attribute number, and access, whether it's read or write. The virtual meter can be set up with all your OBIS codes by modifying the initialization file, and then you can run your tests. Or in fact, leave the OBIS codes as they are and just modify the head-end system. Remember that to get back to the default values for the meter, simply delete the INR files, restart the program, and they will be regenerated with the default values that you see here. The virtual meter will also show the commands and responses in the communication window for debugging. So remember, we'll let you know as soon as this is ready. It's currently being tested. Once we're happy with it, we will release it for field testing. We will welcome all of your feedback. If there's anything we haven't implemented correctly, we'll make the relevant changes. In the meantime, I'll see you in the next video. Thank you very much. This brings us to the end of this part of the video series. I hope you found this video helpful, and I hope to see you for the rest of the video series. Goodbye, and see you again soon.